solutions to these two equations. So there are two parts to this question. Part 1 is sine 2x plus cos x equals 0, and part 2 is sec squared 2x equals 1 minus tan 2x. Now whenever we are given these generic trigonometric equations whose solution we are expected to find, our first attempt should be to convert them in terms of product of different trigonometric functions as being equal to 0. So for example, if let us say a, b and c are three different trigonometric functions, and somehow we can express an equation in terms of a times b times c equals 0, then we can say that this would be satisfied if a is equal to 0 or b is equal to 0 or c equals 0, and then we can try to solve each of them separately and come up with the possible solution to the original equation. Now let us look at the first part to the problem, sine 2x plus cos x equals 0. Now we have two terms here, sine 2x and cos x, and there's an addition of the two terms. So if we can find a common term between the two, we can probably convert this into a product of two trigonometric functions. And we already know that sine 2x can be written as 2 times sine x cos x, and therefore cos x is what can be taken as common between the two. Let us try to do that. So in part 1 we can write the equation as 2 sine x cos x plus cos of x equals 0, and that becomes cosine of x multiplied by twice of sine of x plus 1 equals 0. Now the product of these two functions would be 0 if either of them is 0. So this implies that either cos x is 0 or 2 sine x plus 1 is 0. And this implies that when cos x equals 0, then we know that x must be an odd integer multiple of pi by 2, that is 2n plus 1 pi by 2, where n is an integer, and 2 sine x plus 1 equals 0 implies sine x equals minus 1 by 2. Let us now try to write this second equation as sine x equals sine y, where y is a particular solution. And we know that, for example, sine of 30 degrees is 1 by 2. So therefore we can write this as minus half as minus sine of 30 degrees, which is minus sine of pi by 6, right? And now we need to remove that negative sign because we want to express this in terms of sine x equals sine y. And we already know that sine of pi plus y is equal to minus sine of y. And therefore we can write minus sine pi by 6 as sine of pi plus pi by 6, which is sine of 7 pi by 6. So we have got our equation sine x equals sine 7 pi by 6, and we know that the solution to that, the general solution to that equation is x equals n pi plus minus 1 raised to the power n times 7 pi by 6, where n belongs to the set of integers. Therefore these two are the possible general solutions to the first equation. Let us now look at the second part of the question, sec squared 2x equals 1 minus tan 2x. Now we know that sec squared y can be written as 1 plus tan squared y. So therefore sec squared 2x can be written as 1 plus tan squared 2x. And we can see that 1 would get cancelled on the two sides, and we can get tan 2x as common. So let us write that. So we express sec squared 2x as 1 plus tan squared 2x, which is equal to 1 minus tan 2x, and we cancel 1 on both the sides, and this therefore can be written as tan 2x times tan 2x plus 1 equals 0. Now please note here that we did not cancel tan 2x on the two sides, because tan 2x equals 0 is one of the possible solutions. And if we removed tan 2x, then we would lose that solution. So you should be careful to retain all the variables. Now this implies that either tan 2x equals 0 or tan 2x equals minus 1. And the solution for tan 2x equals 0 is the same as the solution for sin 2x equals 0, because tan 2x is sin 2x by cos 2x. And at the same time, cos 2x cannot be equal to 0 because tan 2x has to be defined. So therefore, the solution to first equation is 2x equals n pi. That is, x equals n times pi by 2, where n is an integer, and as we said, cos 2x cannot be 0. So we write the condition that 2x cannot be equal to 2n plus 1 times pi by 2, or x cannot be equal to 2n plus 1 times pi by 4. Now let us look at this other equation, tan 2x equals minus 1. And let us try to express that in the form of tan 2x equals tan y, where y is a particular solution. Now we know that tan pi by 4 is 1. Therefore we can write minus 1 as minus of tan pi by 4. And we also know that tan of pi minus y is minus tan y. Therefore we can write minus tan pi by 4 as tan of pi minus pi by 4, which is tan of 3 pi by 4. So we have the equation tan 2x equals tan 3 pi by 4, and we know that the general solution for that equation would be 2x equals n pi plus 3 pi by 4, and therefore x equals n times pi by 2 plus 3 pi by 8, and that is our second possible solution. And the first possible solution was x equals n pi by 2, with the condition that x cannot be equal to 2n plus 1 times pi by 4, where n belongs to the set of integers. And that completes our answer to question number 10, and it also completes session number 2 of practicing trigonometric problems. And now I will see you in the third session, where we'll look at more problems.